we have to deal with one more motion, which is rotational motion. So today we'll continue with rotational motion. It is the second part of rotational dynamics. We will consider few characteristics of this rotational motion. When body rotates or in rotational motion, body rotates about an imaginary line passing through itself. That imaginary line about which the body rotates is called axis of rotation. So first characteristics in rotational motion, body rotates about an axis of rotation. That axis passes through itself. So body as a whole, if you consider, it rotates, but body is made up of number of particles. Consider one body made up of n particles. So different particles are situated at different distances. Let the body be rigid and it is rotating about axis passing through suppose point O. Then different particles of the body are situated at different distances from the axis of rotation. The second characteristics is this rotational motion has sense of rotation. It may be anti-clockwise or it may be clockwise. So when body as a whole rotates, each and every particle traces circular path. The circles of or centers of all these circles of all particles are situated on the axis of rotation. But these particles have same angular velocity. So when body rotates, it acquires angular velocity. Suppose body is rotating in anti-clockwise sense with uniform speed, that is angular velocity is constant. Then each and every particle of the body will cover circular path with same angular velocity as that of body. So omega for each and every particle is same, but being situated at different distances. Suppose particle of mass m1 at distance r1, particle of mass m2 at distance r2, and so on. Linear velocity of these particles varies from one to another. So you know the velocity, linear velocity related with omega, with expression r omega. So even omega is same, being r different for different particles from the axis of rotation. Each particle will have different linear velocity. Different, it is also called translational velocity. So what happens on account of rotation, each particle will acquire translational kinetic energy, which is given by formula half mv square. Per particle, translational kinetic energy will have different value. When you add translational kinetic energies of all particles together, we will get rotational kinetic energy of the body. So rotational kinetic energy is equal to sum of translational kinetic energies of all particles. So first derivation we will start with is expression for kinetic energy. So write down the क्वेश्चन लिखे लो. Derive the expression for derive the expression for rotational kinetic energy of rotating body. Expression for rotational kinetic energy of rotating body. So here we assume body under consideration to be rigid one. Rigid. Rigid means what? If small force is applied on the body, the distance between the two particles doesn't change. That is called rigid body. So we will consider one rigid body consisting of n particles. Suppose of finite shape, not much huge. So you can have the derivation. This is we assume rotating about axis. Suppose that axis passes through point A. And we assume it is rotating with uniform angular velocity. For simplicity, suppose in anti-clockwise sense, ऐसे assume करते हैं कि anti-clockwise sense में body rotate हो रही है with ohm. We will assume the masses of n particles to be m1, m2 up to m capital N. Let these particles are situated respectively at the distances r1, r2 up to rn from the axis of rotation. ये हम लोग assume कर रहे हैं. We will consider a particle of mass m1 situated at point A at distance r1 from the axis of rotation. Similarly, rest of the particles of mass m2 at certain point B at distance r2. Last particle of mass mn at distance rn at point n from the axis of rotation. All particles will trace circular paths of different radii. We will consider motion of particle of mass m, suppose situated at A. So what will happen when body rotates? This particle will trace the circular path of radius equal to r1. During this motion, it will have, being in circular motion, it will possess linear velocity. So you consider linear velocity of particle of mass m1 situated at point A. So what will happen? The linear velocity with which this particle is in circular motion, we can write as r omega, that is distance r1 omega. On account of this linear velocity, it will possess translational kinetic energy, that is linear kinetic energy, because this is linear velocity. So we will assume translational kinetic energy for particle 1 will be then half mass is m1 v square, that is v1 square, that is r1 square omega square. This will be true for each and every particle. So we can write for last nth particle of mass mn, translational kinetic energy to be half mn rn square omega square. ये सब हो जाएगा. And thus, if you add all these together, you will get rotational kinetic energy for the entire body. So, we can find rotational kinetic energy of the body with adding all translational kinetic energies of all particles together. So, resultant rotational kinetic energy or the rotating body will be then the sum of kinetic energies of all particles which are of translational type, linear type. So that will be then half m1 r1 square omega square. For second particle, half m2 r2 square omega square up to the last particle mn, half mn rn square omega square. This expression you will get. And thus making omega common, it is summation of all terms. देखो कैसे हम लोग लिख सकते हैं, हाफ इज कॉमन, ओमेगा स्क्वायर इज कॉमन, इन ब्रैकेट यू कैन राइट m1 r1 square plus m2 r2 square up to mn omega n rn square. So in the bracket you get term sum of product of mass of particle and square of its distance from axis of rotation. You can write it as summation particle number running from 1 to n mi r I square हाफ into ओमेगा स्क्वायर. ऐसे भी हम लोग लिख सकते हैं. You can replace this with summation sign. If you let the quantity in the bracket by symbol suppose I, then you get rotational kinetic energy half I omega square. This is the first derivation of in rotational motion. I have told you what you feel important during the lecture. You have to note down in your notebook. आप लोगों को नोटबुक में ये सब कॉपी करना है, नहीं तो आप लोगों को ये क्वेश्चन बाद में लिखना है. सो रिमेंबर दिस. सो इफ यू कंसिडर I, we have replaced mi ri square summation by symbol I. So this is first expression. So this is introduction for I. If you take analogy with the linear expression of kinetic energy, in that is kinetic energy in linear motion, straight line motion, that is translational motion. In translational motion, we represent kinetic energy by expression half mv square. In rotational motion, kinetic energy we write by expression half I omega square. So if m is replaced by I, v is replaced by omega, these two expressions are analogous. Analogous है इसलिए हम लोग क्या बोल सकते हैं, I should play the same role as that of mass playing in a translational motion. So I क्या है, it plays the same role placed by m in translational motion. M क्या है, it is inertia. It opposes the motion of the body. So opposition for motion is governed by mass in translational motion. Similarly, opposition for rotational motion by the body should be governed by this quantity and it is called moment of inertia. Not movement, it is movement of inertia. It is also called as rotational inertia. उसको रोटेशनल इनर्शिया ऐसा भी बोला जाता है. So with analogy you have introduced or we have introduced with new term I in rotational inertia. So I is summation of mr square. So I does not depend only on mass of the body, it also depends distribution of mass of the body about the given axis. If I change the position of axis, जो मैंने पार्टिकल लिया था of mass m1 at distance r1, initially placed at point A, ये जो एक्सिस हम लोगों ने डेरिवेशन के लिए लिखा था. If I change the position of axis, let the axis now passes through point O dash. ऐसा हम लोग एज्यूम करेंगे. तो डिस्टेंस ऑफ पार्टिकल m1, उसका मास चेंज नहीं हुआ है, वो पार्टिकल सेम ही है, लेकिन उसका डिस्टेंस फ्रॉम एक्सिस ऑफ रोटेशन चेंज हुआ है. नाउ इट हैज बिकम r1 dash. So what will be product m r square m1 r1 dash square. पहले वाला क्या था, m1 r1 square था. अभी वही पार्टिकल के लिए एक्सिस पोजीशन चेंज किया तो क्या हो जाएगा, इट्स मूवमेंट ऑफ इनर्शिया अबाउट द गिवन एक्सिस m1 r1 dash square. So moment of inertia of each particle about the axis of rotation changes due to change in position of axis, and hence summation of mr square for the entire body also changes. So I not only depends on mass of the whole body, but it also depends on distribution of mass of the body about the axis of rotation. If larger the distribution of mass means from axis, the body has larger mass distribution, then moment of inertia will be greater. The opposition for the motion offered by body will be then greater. ऐसा रहता है. So I का वो physical significance है. So this moment of inertia plays very important role in rotational motion of the body. We have assumed body to be rigid one. So what happens when body rotates about the given axis of rotation? It will get angular velocity. If angular velocity is changing, for example, the fan is made on, then gradually its angular velocity will go on increasing and it will possess angular acceleration. तो क्या होता है, जब भी बॉडी रोटेट होती है तो इट एक्वायर्स एंगुलर एक्सीलरेशन. यू कैन कीप दैट वैल्यू कांस्टेंट. जैसे लिनियर मोशन में जब भी हम लोग फोर्स लगाते हैं तो उसमें लिनियर एक्सीलरेशन डेवलप हो जाता है, वैसे ही व्हेन बॉडी रोटेट्स देन it acquires angular acceleration, means there should be certain force acting on body while rotation, means the force should act on the body to make it rotated. अभी शुरू में बॉडी एकदम स्टेडी है, अगर उसका रोटेशन चालू करना है तो अपने आप बॉडी चालू नहीं करेगी. यू हैव टू प्रोवाइड फॉर फोर्स. The force required to rotate the body about the given axis is not singular. We require a pair of forces equal opposite acting at two different points. ये एक फोर्स है, ये एक फोर्स है. ये डस्टर है, ये डस्टर को मैंने रोटेट करना है. इट शुड नॉट ट्रांसलेशन नहीं होना चाहिए, उसका रोटेशन होना चाहिए. तो मैं क्या करूंगी, ये साइड एक फोर्स लगाऊंगी, ये साइड अपोजिट फोर्स लगाऊंगी, तो बॉडी विदाउट ट्रांसलेशनल प्योर रोटेशन में ला सकते हैं. सो टू इक्वल अपोजिट फोर्सेस एक्टिंग एट टू डिफरेंट पॉइंट्स ऑन द बॉडी सेट्स द बॉडी इन मोशन. What is the effect of such pair of forces acting? They produces torque. कपल तैयार हो जाता है और मैग्नीट्यूड ऑफ कपल वी विल कॉल एज टॉर्क. सो टॉर्क इज एसेंशियल टू सेट एनी बॉडी इन प्योर रोटेशनल मोशन. विदाउट ट्रांसलेशन इट स्टार्ट्स रोटेटिंग अबाउट इमेजिनरी लाइन व्हिच वी कॉल एज एक्सिस ऑफ रोटेशन. सो टॉर्क प्रोड्यूसेस indirectly we say angular acceleration. So there should be certain relation between cause of rotational motion and acceleration produced in the body during that motion. So we will proceed further to find out expression between cause of rotational motion and acceleration with which that body rotates during rotation. So this is second derivation. It is point number, open the book, page number 17, पॉइंट नंबर 1.9 मैंने डायरेक्ट टॉर्क का डेरिवेशन चालू किया है. आई हैव स्टार्टेड विथ रोटेशनल मोशन. इट वाज ऑन पेज 12. पेज 12 पे 1.5 जो पॉइंट है उधर हम लोगों ने स्टार्ट किया. सो वी डिराइव एक्सप्रेशन फॉर काइनेटिक एनर्जी. विथ काइनेटिक एनर्जी इट व्हेन इट मूव्स it will produce acceleration. Let assume angular acceleration is constant, and when you set the body in pure rotational, singular force is not sufficient. Torque should be acted on the body. एक टैब है, वाटर टैब, उसको आप लोगों को खोलना है तो खाली सिंगल फोर्स देते हैं क्या? दोनों बाजू फोर्स लगाते हैं ना. ये बाजू लगाते हैं और ये कैसा लगाते हैं? उल्टा लगाते हैं. तो एंटी क्लॉक नहीं तो क्लॉक ऑन एंड ऑफ करने के लिए टू फोर्सेस आर नेसेसरी, एंड हेंस इनडायरेक्टली वी से torque must act on the body to set in pure rotational motion. So torque produced on the body gives angular acceleration. So we consider the body consisting of n particles, masses m1, m2 up to mn, situated at distances r1, r2 up to rn from the given axis of rotation. We will assume the body to be rigid, rotating about axis through point O, suppose in anti-clockwise sense with constant angular acceleration alpha. हम लोग ये assume करेंगे. So what will happen when this is the case? On account of, I have told you, whatever you feel is important, you can copy down. So angular acceleration तो constant है, but distances of the particles from axis of rotation are different. So each particle will have linear acceleration, and values of linear accelerations of all particles will differ from each other. What is the relation between A and alpha? A is equal to R alpha. So linear acceleration for particle of mass m1 at distance r1 from axis of rotation will be then r1 alpha. The same we can write for n particle, rn alpha. Since each possesses linear acceleration, each will experience linear force. So linear force experienced by first particle by definition will be ma, that is m1 a1. So that will be m1 r1 alpha. You can continue for last particle mn rn alpha. ये तो हो जाएगा. And when you find linear acceleration, each will experience torque. Torque तो होने वाला ही है. So torque और force में definition क्या है? Magnitude of force and moment arm is equal to torque experienced by that particular object. So by using these F expressions, you can find torque experienced by first particle, that is magnitude of force, into momentum, that is perpendicular distance between these two forces. ये एक force है, हम लोगों ने pivot की है ना, जब ये body rotate होती है, means what? Indirectly you are pivoting it at point O, so that it will freely rotate about the point of pivot. पाइवोट करते हैं ना बॉडी तो रोटेट हो सकती है विदाउट ट्रांसलेशन. सो पाइवोट करते हैं. पाइवोट यानी कि दिस इज आल्सो द फोर्स, दिस इज आल्सो द लीनियर फोर्स द बॉडी इज एक्सपीरियंसिंग, एंड ये डिस्टेंस बिटवीन द टू फोर्सेस इज मोमेंट r. सो दैट विल बी देन m1 r1. r1 into r1 will become r1 square into alpha. So each and every particle will experience torque. So net torque experienced by body, resultant torque experienced by body, then will be tau 1 plus up to tau n. So that will be m1 r1 square alpha up to mn rn square alpha. When you write it in terms of making alpha common, taking all terms, mr square is common. So you can write it is as mri square, where summation runs from particle 1 up to particle n. And by definition, this is nothing but moment of inertia. So I alpha. So tau is always equal to I alpha. So in this expression also, you can take analogy. Torque is responsible for rotational motion, while force is responsible for linear motion. So F is equal to ma, while we get tau is equal to I alpha. So A is replaced by alpha, then A is replaced by I. These two equations will be analogous. So again this I plays the same role as that of the role played by mass in linear motion. So this moment of inertia is very important. It plays very important role. It always opposes the rotational motion of the body and also called rotational inertia. Only the difference I depends on not only mass के ऊपर depend है ही, लेकिन distribution of mass of the body about the axis of rotation. If the position of axis is changed, then you will get change in moment of inertia of the same body. ये जो body है ना, ये same है. Only I will change the position of axis. Then the particle which was lying earlier at distance r1 now will lie at distance r1 dash. So particles moment of inertia individually changes, which changes the moment of inertia of the whole body. So moment of inertia is a new term. It is very important. Its physical significance, it plays the same role as that of mass in linear motion. It not only depends on mass of the body but also depends on distribution of mass about the axis of rotation. But suppose if the body is very huge, made up of infinite particles, ये हम लोगों ने फाइनाइट पार्टिकल्स लिया ना प्रैक्टिकल पर्पस के लिए, ऐसे भी हो सकता है. तो इनफाइनाइट पार्टिकल्स में अगर बॉडी है तो इट इज जस्ट इम्पॉसिबल to find moment of inertia of each and every particle. Instead what? This summation we replace by integration. If the mass distribution is integrable, अगर ये mass distribution को हम लोग homogeneous है, उसका integration ले सकते हैं, तो summation we can replace by integration. Mass of body into distance r square. So for definite body, I is summation mi ri square, where I runs from 1 to n. For huge body made up of infinite particles, this summation will be replaced by integration. Only the condition, the body mass distribution should be integrable and homogeneous. नहीं तो integration नहीं ले सकते. So you can replace it by mass of the body into r square, and this r is called radius of gyration. We can use this integration as mk square, where k is radius of gyration. So we'll proceed further tomorrow with significance of radius of gyration. Today I am closing the meet.